Hello, this is Coding Gicha for full-stack developers. In the previous session, I covered how to connect to MariaDB from PHP via PDO MySQL to retrieve data and how to manage PDO information using any configuration file. I will now explain how to handle transactions in PHP while implementing a delete query, in addition to the BOM list and detail view features that were implemented to explain the previous videos. I will implement a feature where deleting BOM information from the BOM detail view screen removes the BOM and its data and redirects to the BOM list view screen. Let's launch Visual Studio Code. In the detail.js file, I will implement the event handling for when the remove button is clicked in the detail.php file. I will retrieve the HTML element object of the remove button. When the remove button is clicked, I will send a deletion request to the server asynchronously. I need to know the BOM ID to be deleted. Currently, the implementation is set up so that the BOM ID is passed via the get method to retrieve BOM detail information. The get method is a request sent to the server that appends parameter values to the end of the URL. I will extract the query string from the URL address and construct an object containing the parameters from that string. Finally, I can retrieve the BOM ID from the parameter object. URL addresses can be bookmarked or shared. Since parameter values are included in the URL, this can be useful but also susceptible to misuse. Furthermore, requesting an address with unused or deleted BOM ID information may cause errors. Due to time constraints, I used request parameters with the get method here, but it is advisable to use the post method or receive request parameters through internally secure logic. I will re-implement this for cases where request parameters are not passed in the URL address for various reasons. The simplest method is to hide the request parameters within the code rather than in a visible URL. I will set the BOM ID in the data attribute of the remove button. Of course, this information can be found by viewing the source or using developer tools, but since that process is cumbersome, it is safer than the get method. If implemented using a framework like SPA, data is internally bound to a sandbox and APIs retrieved from the bound data are provided, making implementation safer and more convenient. However, since such a framework is not being used here, I will conclude at this point. In JavaScript, the value set in the data attribute can be read and written as the dataset property. I will make an asynchronous deletion request to the server using the fetch function. I will use the post method for the request. While values could be sent to the server in form URL encoded format, I will send the data in the language-independent JSON format. The JSON format has the advantage of being usable with various types of values and values with a hierarchical structure. I will re-implement this to handle such situations. If the deletion process is successful, I will navigate to the BOM list screen to verify that the corresponding BOM has been removed from the list. If the deletion process fails, I will display a message in an alert window. I will create a PHP file to implement the deletion process. I will retrieve PDO information from the ini configuration file and creating a DB connection object using the method explained in the previous video. Since I need to delete both the BOM and the BOM data, a transaction is required. Once a transaction begins, it must ultimately be completed by performing a commit or rollback. The request information was passed from the client to the server in JSON format. When data is passed via the post method, the values are returned in the request body. By reading the string contained in the request body and decoding it into JSON, I can convert the values of the JSON object into an associative array. Since I will be deleting the BOM and BOM data corresponding to the BOM ID, I will create an associative array in advance that binds the values to be used commonly within the prepared statements that will execute the SQL queries. I will declare an associative array to store the final result values. I will wrap the SQL query execution logic in a try-catch block. Once a transaction begins, it will hold onto the connection until a commit or rollback is executed. Each database has a fixed limit on the number of connections, so caution is required as the database may become unusable if connections continue to accumulate. I will create a prepared statement for the SQL query to delete the BOM data. I will execute the statement by passing an associative array as a parameter to handle the variables used in the prepared statement. If the BOM data has been deleted, the BOM itself must also be deleted. If both SQL queries are executed successfully, I will set remove to true. If an exception occurs, I will set remove to false and include the error message in the result. I will process the response with the content type set to JSON. In the response body, I will encode the result associative array into a JSON string and send it. An error may occur if the address remove.php is requested arbitrarily. I will prevent errors by handling requests made via the get method, which will display a 403 forbidden message and terminate the process. The display of a 403 forbidden message actually indicates that the file exists. By displaying a 404 not found message to make it appear as if the file does not exist, it can confuse hackers and provide greater security stability. I will now check the data used for the screen implementation in the database client. The BOM table contains skateboards and ladder backchair. The BOM datas table contains data related to skateboard and ladder backchair. I will navigate to the detailed information screen for the ladder backshare. I will click the Remove button. If the deletion process is successful, I will be redirected to the BOM list screen. I will call the remove.php page arbitrarily. When called via an invalid path, a 404 not found error screen is displayed. Since only the skateboard is visible on the BOM list screen, I confirm that the ladder backshare BOM has been deleted. However, I will verify in the database client whether the BOM datas related to the ladder backshare have actually been deleted. Only the skateboard related datas remain in the BOM data. I will check the data definition language of the BOM datas table. The BOM ID has a foreign key configured to reference the BOM table. Foreign keys prevent data errors by preventing the insert of values into a child table that do not exist in the parent table. Furthermore, if data referencing the parent table exists in the child table, modification and deletion are originally impossible. Foreign keys prevent data errors by preventing the insertion of values into a child table that do not exist in the parent table, and if data referencing the parent table exists in the child table, modification or deletion of that data in the parent table is also fundamentally impossible. Setting referential integrity constraints enables modification and deletion. If you configure the onDelete cascade, if data is deleted in the parent table, all data referencing it in the child table is also deleted. To ensure that if data in the parent table is modified, all data referencing it in the child table is also modified, you can use the onUpdate cascade. However, since the keys in the parent table configured as foreign keys are mostly primary keys, there is rarely a need for key modification. Therefore, you will primarily configure only the onDelete cascade. Since the delete cascade is configured on the foreign key, deleting data only from the BOM table will automatically delete it from the BOM datas table as well. In other words, you only need to execute a single SQL query. Since only one SQL query is executed, you honestly do not need to use transactions. While database handling methods differ by programming language, PHP supports auto-commit, so it is safe from the risk of continuously holding onto a connection by missing to commit, rollback, or close the connection. Perhaps, if the foreign key is configured correctly, you might not even need to handle transactions programmatically. However, foreign keys are not a panacea. While they provide the benefits of data integrity, they also increase costs. If data modification operations such as inserts, updates, and deletes are more frequent than data retrievals, performance degradation is inevitable because data integrity between parent and child tables must be calculated for each operation. There is also a risk of increased waiting times and deadlocks as locks are placed on the reference tables while data integrity is being checked. When migration is required for an application currently in use, constraints on table structure changes and data modification operations lead to increased operational costs. If foreign key relationships are too complexly intertwined, the database optimizer may fail to find the optimal execution. Personally, I believe it is best to set up only the minimum necessary relationships and avoid configuring referential integrity constraints such as onDelete cascade. Implementing transactions programmatically is more effective for performance optimization than relying on referential integrity constraints. Setting up foreign keys clearly has the effect of preventing development from going in the wrong direction during the development phase. This is because if foreign keys are configured, the SQL query execution order and transaction implementation must be aligned to ensure error-free execution. If the application is properly implemented during the development phase without being misdirected by foreign key settings, building the database without applying foreign keys when deploying to actual production may be a better way to achieve improved performance. Thank you for watching.